Is my screen showing?
Yes.
Okay, great.
But
yeah, I'll put it on presentation mode now. Yeah, so usually this section is, we call it, it's HVAC, but, heating is so rarely needed anywhere on the Cayman Islands. So we don't really, we save a bit of time by not talking about that. Actually, we're talking about energy efficiency, energy efficient air conditioning, but really that this whole section or intent is to cover both systems and appliances, because as I mentioned earlier, whatever we put into the buildings have the potential to be there for a very long time. And the longer they are there and the less efficient they are, they will, use more energy over their lifetime. That has, significant impact on the energy consumptions and the emission and the cost to operate the building. I think in the chat, somebody had mentioned lifetime costs, and that's true. If you put energy efficient equipment and appliances into the building, you do reduce not just the immediate cost, but also costs over a lifetime. So we do need to compare the initial cost against the lifetime cost to get a better picture. Most of us tend to just shop based on the initial costs, but energy using products have what they call the hidden price tag, which is the energy consumption, the energy costs that it requires to operate these appliances over time. So definitely, it's something that some of the informed customers will be looking for, and it's a good way for us to be able to answer those questions when your clients ask. Okay, so first we'll deal with ventilation and air conditioning. It is one of the key components of houses now is to have an AC unit, and the operation of air conditioning is about 40% of electricity consumed in homes. Actually, it's probably more in the tropics, but 40% is reasonable. Again, it does depend on what other equipment that you have in the homes. We know that if people use incandescent lamps, for example, or halogen, it adds to the heat load. So that, that will in turn sort of, I guess the analogy is snowball, but yeah, it adds to all the operating costs. So higher efficiency, the more efficient the air conditioning system, the better it is able to reduce energy consumption and costs and improving user comfort. And as I said before, the incremental cost of the first cost of an energy efficient system is generally returned through the lower electricity costs, lower operational costs over the life of the unit and over the life of the building. Many jurisdictions now, like the EU, North America, other places, have regulatory requirements for energy efficiency of residential AC system. It's not specific to the homes, but they have specific requirements on how efficient a unit needs to be before it can be sold on the market. So it's something that, it actually will help many builders, because I know many builders source their equipment through, US dealers or whatever. And, if you go through those dealers, the energy efficient equipments are already there because they're required by law to only have, to meet minimum energy efficiency requirements. So AC efficiency, there's a number of factors to consider when you choose an AC unit. They are rated through uh, what's called energy efficiency ratio. You see the EER label on the equipment, or more commonly, what you see is the SEER, which is the how efficient the system is through adjusted or seasonal usage. Um, One of the other key factor to choose would be the system sizing. If you need to match the system to the load to make it more energy efficient, because if you choose a system that's running infrequently or running all the time, both of them are not means that it's not quite properly sized to the load at hand or the work that it needs to do. Newer technologies now allows you to choose many, or they have many components that make energy efficient AC, the units more energy efficient, such as inverter technology and smart thermostat. All of those add to the energy efficiency of conventional air conditioner units now. There's a nice picture here from the US DOE, but we won't need to go into that. Yeah. So again, as I said, there's the EER or the SEER rating for as energy efficiency rating for ACs. In actuality, the EER rating, that energy efficiency rating that's used, less seen, is actually better suited for hot and humid climates. This is because the two ratings, they use similar testing method, but the testing conditions vary between the way the two tests are applied. The SEER actually measures the cooling efficiency over a range of outdoor temperature, 65 to 95 degrees F. So it provides a broader measure of how the air conditioning system actually operate over different temperature ranges. The cooler temperature outside, of course, makes the system more efficient because it doesn't have to exhaust as much heat. The better temperature difference actually allows it to work better. The EER measures cooling efficiency at a constant temperature, typically 95 degrees F, which is in this case is more applicable to conditions on the Cayman Islands. You rarely see 65 degrees F, and at 65 degrees, you would hope that most people don't really require air conditioning. But so that's the difference. Now, actually, there's another twist to to this rating. The US DOE actually has also introduced another rating called the SEER2, which is a newer rating system, and it's based on an updated testing methodology. There is there's a comparable or equivalency chart between EER and SEER and SEER2, and we'll show that later. I just want to mention about SEER2 and actually also EER2, because you will be, it's not as common yet especially in Cayman Islands, but eventually it will be coming, because it's well, unless the new government administration in the US revokes it, you will be, units that are sold in the US, in North America, will start displaying SEER2 and EER2 ratings. So it's just something to prepare, that you should be aware that this is coming. Okay, so as we mentioned before, there's these ratings that we can use, and of course, the higher the rating, the more energy efficient um, the system, the equipment. So the general recommendation, of course, is to choose a unit with a high SEER that's feasible or affordable or available. Um, many places, many jurisdictions require 14, but 16 is better, and 20, which units that have 20 SER now are available, and they'll give you the most energy savings possible. And as I mentioned, these, the more energy efficient units, they incorporate things like inverter driven compressor, so that they, and also they have variable pump speed, fan speed, and all of these help to maintain a stable indoor temperature without stressing the system, so they're more efficient. Another thing to be aware of, and this actually applies to many more pieces of equipment than just AC, but make sure that they are tested or certified equipment. Don't if the dealer said, oh, these are SSEE, SER 20, I would not just take their word for it. Make sure that the supplier shows you the test that it's been done, and or different certification that these units um, comply with, so that to make sure that they actually operate as claimed. And of course, this is a preview for and a sales pitch for the next presentation next week, the training next week, because we'll talk more about energy efficiency labeling and how to source products. So hopefully this will bring more of you to the other presentation, the other training as well for next week. So back to the certified or tested equipment. So, AC units with Energy Star labels indicate that they're compliant with the efficiency guidelines. Same thing, Alex was talking about selecting windows earlier, right? So windows also are tested by the Fenestration Council. So windows would label, that they're tested by the Fenestration Council are, the rating is more believable than just random claims by suppliers. So just definitely make sure that when you choose unit, what the criterias are, but also when you know the criteria, make sure that they're certified, they're proven, so that you're just not choosing things based on spurious claims. So here we are. We have the table for the different AC rating. So you see that the SEER, and then in the parentheses, the SEER2 values. So the SSER2 values are there, and also the EER values are also here. So this is the table of equivalency that hopefully will you can use to do the selection. But we've highlighted at least 16, which is at least the minimum requirement value, minimum value that we recommend you consider. 16 SEER is the equivalent of 12.8 EER. And many places, if you can afford it and it's available, go to a higher value, right? So 20 is better. So, and this table is actually available in the guide, in the guidelines. So it's and it'll be here for you to choose. But these are just the minimum values that we suggest you consider. Yeah, so as I mentioned, SSER is now in place, started since 2023. And it's still relatively new and not utilized, but now at least you have the equivalency table, the value, so that you can, if you see an SER2 rating or an EER2 rating, you can at least use that and see the equivalency. And you're not surprised by it, hopefully. So the next part I wanted to cover is that while choosing the energy efficient equipment is key. I mean, if that's the minimum that you can do, as Alex mentioned earlier, in the design process, it's actually better to choose the air conditioner as part of the design process, part of the build process, rather than just, having the plan and then just go out and pick an air conditioner unit and the most energy efficient unit that you can, and then consider that the completion. Properly functioning air conditioning, or just a cooling system, includes many things, and Michael had mentioned that in the chat. The ductwork is part of it. It's about choosing the high efficient equipment. It's about the proper sizing, the appropriate size for the home that you're building, for the cooling load that you will require. The effective ductwork, and then also use where there's a large or very segmented home or two-story home, the use of zoning is a lot more appropriate if you can put that in place. Optimized ventilation, we talked about that, is also necessary, because when you have an undersized or oversized equipment and inadequate ventilation or ineffective ductwork, it can be a recipe for disaster. So the system design process, this is the chart that it's from, that the CBAC. This is the process, and they recommend the manuals that you use. We put a lot of that information here, but I'm not going to go through that in detail, because we'll run out of time, and also it's a lot to consider, and so I'm just putting this here so that you are all aware of the sort of the process required. Many of you are already aware of it, but this is just a reminder that what an effective air conditioning and ventilation system, what you really need to go through. So in terms of where the CBAC is, it does not have explicit instructions on cooling loads, but it references a number of standards for detailed procedures. It either refers to the ASHRAE handbook on fundamentals, or it refers to the handbook that's put out by the Air Conditioning Contractors of America, the ACCA, for specific methodologies for calculation of cooling loads. So these handbooks, I'm going through it. You can see that this is the optional slide for geeks. It does talk about specific process, either the ASHRAE handbook or the manual J, and they talk about the heat balance method of the radiant time series, or the cooling low temperature difference method. So these are different methodologies that you can use to calculate the cooling loads. And then the ASHRAE handbook and the ACC manual J also recommend that you have to consider the envelope characteristics, consider occupancy and internal gain. So if you're building a building that you are expecting lots of occupants versus for just a 2 or 3 people, they do you need to take those into account for the load calculations. Local climate conditions, very important. We know that where we are is hot and humid, so that should be part of the calculations. So I'm just going to talk about the proper sizing, right? So best practice, again, talk about building envelope and internal gains and local climate condition. So all of these taken into consideration ensures that the system is not undersized. So it, it runs all the time, but it doesn't provide enough cooling, or oversized. So it only runs in very short bursts, and it cools everything down intensely and then stops. And it can cause moisture, ventilation, and humidity issues. Um, so, those are consideration that you can avoid if you use the manual J calculations or the methodologies specified by uh, the ASHRAE manual. So again, ASHRAE and these are really useful references that I recommend. So, the manual J is the residential road calculations. The ACCA also has a manual on the residential duct system. So, they talk about the proper sizing for ducts, duct design, uh, duct location, whether it should be in conditioned areas of the house or unconditioned areas of the house. So all of those are touched in here. Um, so they are, know that these manuals, JD and S, are the standard for residential AC design. And they are recognized by virtually all mechanical and building codes. It's used through, like modeling software like ResNet or Energy Star, and other organizations also recommend that. The IBC and the CBEC identified these as references, right? And the proper design is achieved by using these. So yeah, so I mean that's one of the things that these really help is improve insulation, air sealing, and proper sizing is the way to go. Bigger is not necessarily better in this case. You don't want the largest AC unit possible. It could be a good bragging right that you put the most capacity in a house, but that might not result in occupancy comfort or satisfaction. Other key best practices and reminder, in the manual D method, it talks about duct material, different static pressure, proper sizing and sealing, balanced airflow, which are all key for comfort. So there is one thing I want to note is that actually the materials that I just referred to, the duct sizing calculation and all of that, the details, we have put actually a little bit more detail in this presentation than actually what is mentioned in the guideline, because the guideline, we talk more about choosing an energy efficient equipment. And all of these are other sort of references that you should consider. And for many of you, the designers and the architects who are here, I mean, these are the things that you train for. So these are just reminders and sources of references for you. Many of you are much familiar with these processes, and especially if you work with commercial buildings. So this is just intended just as a general session. So that's why I'm not going into deep details. So let's talk about, other options that you have. Zoning is a way, and sensor-based cooling. So now many thermostats and smart thermostats and AC units, like split units, you have the ability to do zone cooling as opposed to one cooling, cooling using applying the same cooling for the different areas. So multiple cooling zones can help efficiency. You can, dampers or separate thermostats so that, unoccupied areas are not necessarily cooled. Smart sensors help with that. My little Ecobee sensors now, it senses when I walk by it, so it knows when I'm home, and it adjusts my home temperature accordingly. Those things are very useful to have, and the use of split systems for individual rooms, as I said, can also help with efficiency. Other things that you can do with the automations and the sensors and the tools that are available to you now. You can have optimized cooling schedules. So users can program temperature settings, if they have daily routines, people work, or they work from home, they can have different zones, condition, operate, independently from others. Remote access and control. So the Wi-Fi enabled sensors can help with the adjustments. People now have apps on their smartphones, so they can, control the home temperatures from even when they're away from homes. So it's something it's very useful. You can, if you leave the house in a hurry, you can always use the app to lower, to not low, but in my case, lower the temperature. But in this case, they can increase the temperature when the home is unoccupied. There's AI thermostats now, so they learn the patterns of the occupants when they're in, when they're out, and it takes over the difficult part of programming the units. Zoning integration, yes, sensors, so you can have independent zone controls. Another thing that's very useful are a lot of the smart thermostats now have humidity sensors. So that allows the occupants to operate the units in such a way that it minimizes the humidity without, build up. So those are really, again, useful tools that are in your toolbox that can be integrated into the homes. It becomes a feature of the home that you can sell to potential buyers. Better comfort level because of things like humidity control, zoning, and all of that increases better indoor air quality, better just better comfort in general. So they're all become really good selling points for a home. Another feature that's not as fully realized are the use of ceiling fans. Ceiling fans can provide additional comfort, right? They can circulate air. One of the factor that psychologists find when they study human comfort is that even though we're in the same room with the same temperature, having air movement actually make you feel cooler, right? So but the ceiling fans can help with that. You can run the ceiling fan, and it helps with cooling instead of turning on the AC. So that's another way to reduce energy use. Poor circulation can, in either older homes or homes that are being refurbished, you might not be able to fully do the duct work or what have you, so it has hot spots, or rooms with very large windows have hot spots. So with the hot spot to humidity, the ceiling fans can help with that. It can also help with cross ventilations. So ceiling fan energy efficiency, again, they have different energy efficiency ratings. So energy efficient ceiling fan can add to reduce the overall air conditioning use and reduce energy use in general. Okay, so how, we mentioned in different areas about smart thermostat and automation. In the guidelines, we have some consideration for users and also for builders to help the occupants set their thermostat. So we recommend that thermostats are the setback features be used. And if it's used, it should be incremental to avoid excessive cooling demand. For example, I wouldn't, if you set the setback too high, and occupants return and they find the house really warm, they all will turn the AC up. Many of us have the habit of turning the AC down past 60 or 65 to 60 or whatever, thinking that it will help the cooling. But most of the time it would just work the system harder, increase energy consumption without improving the cooling factor that much. So setback is one way of doing that. Nighttime adjustment is another one. When we sleep, we can, people can set their thermostat, increase it by a few degrees because it's cooler outside, so it helps with energy consumption. Workday setback, we talked about that already. Smart thermostats allow you to set things like gradual recovery. So again, I have a smart thermostat system. So they, instead of starting, if you set the temperature at a certain point for a certain time, it doesn't start running at that time. It starts running before. So it allows you the house to gradually recover, and that increases the comfort and occupant satisfaction. So people when they return home, they're greeted with cool air, and that makes everybody happy. The fan mode is another way of using the AC units to make them more energy efficient. In the guidelines, we have very specific recommendations on setback thermostat setting. These recommendations were arrived, with stakeholder input. So, these are generally been practiced by builders and occupants and users on Cayman Island, and it works for them. So we put so that's why we have these here, right? So in general, we recommend that a thermostat should be at 78, and nighttime, 3 or 4 degrees higher. Cooling temperature when resident or not home should be set at like 85, 87. It could extend the lifespan of the unit and improve energy efficiency, but it also helped to manage the humidity level in the home, right? And then their extended absence, the unit can shut itself off, and it can do gradual recovery. There are also discussions about best ventilation practice. The ACCA actually has a manual that can be used. I'm referencing it here, but it talks about how to do proper ventilation, the use of energy recovery ventilators. You don't need the heat recovery ventilators, but you need energy recovery ventilators here on Cayman Island. It talks about balanced ventilation. Also filter, if you use filter air intake, it recommends what sort of L filters that should be used. So these are, handy references that are available to you throughout the design process. Okay, so energy efficient appliances, if you have gone through the effort to put energy efficient features in into the building, in the structure, in the homes, the next easy step is to put energy efficient appliance in them. And as many of you know this logo, the Energy Star logo. Um, so builders should consider, they have refrigerators, dishwashers, washer and dryers, dehumidifiers, and thermostats. So all have the Energy Star certification on them. So using them indicate or can result in between 10 and 30% less energy consumption in general. And they're good selling points. People actually are very familiar with the logo. They don't quite know exactly what it does, but it is an indicator of energy efficiency. So they're definitely good selling points for the home. Similarly, energy efficient lighting, not there's the Energy Star requirement for lighting as well, but our recommendation in the guide is, same as the code requirement is at least 90% of the permanently installed lighting fixtures in the home should have high efficiency lamp. So, if you put in permanent fixtures that use screw-in bulbs, you should consider putting Energy Star LED lamps in them, energy bulbs in them, because they do use up to 90% less electricity. You're all familiar with LEDs now. I don't really need to tell you about them. I think I just would encourage their use because they're very effective. It's the most energy efficient transition that we can have, going from incandescent lamps to LEDs. And they're can be used with dimmers to improve energy efficiency. And they last a very long time. So it's a win in so many ways. You can tell when you show the homes, you can say that you have LED lamps, so they potentially don't have to replace their lights for 3 to 5 years, and that's a really nice feature. So just a reminder, Energy Star requires light sources or lamps to be at least 90 lumens per watt, which for today's LEDs, it's very it's so easily achieved that it should be second nature for all builders to just use LEDs. One last thing I want to cover is, of course, I know many homes on Cayman Islands have pools, right? Swimming pools. And that's one of the things that most owners don't realize is pools do use energy. Not, if they heat the water, that's one thing, but even having the pool and operating the pool safely requires a circulation pump. And many of the older pump types only have one speed. So basically, as many of you have the pool pumps need to operate at 2 speed. One is just to, operational, just to circulate the water, and the other speed is to, move the water through the cleaner, through the filter. And the pumps do not need to run at a high speed all the time, but many pool pumps only have one speed. So by just putting a 2-speed or variable speed pump in the pool, you will allow the users, the occupants, to save significant energy. 18% for in-ground pool, and above ground pool at least 10%. So again, and there's Energy Star has an Energy Star pool pump program, But it's just something, again, another area for you to consider, another selling feature for the home. So I will stop my presentation here and take questions or take a break since I've been talking for quite a bit. So, and then we can transition over to the next section. Questions, comments, complaints, any? I'm not able to cheat. Yeah, let me put the chat on, but I actually haven't seen anything on the chat either. So let's see. So there are some chats here. Recommended humidity level.
Hello. Yes, one thing I mentioned is that many lease agreements here in Cayman say you can't turn off the air or leave the windows open. And I've seen some that say even not above 78 Fahrenheit, but definitely they will say not above 80. So obviously that limits some of your options for keeping things efficient. And I think you could probably, get around it with some humidity adjustments and whatnot. But really the issue they have is they don't want you to raise it a few degrees or go on a trip and leave the windows open, and then there's thousands of dollars in mold damage. So there's only so much you can do for a lot of places here. Even even if you own, sometimes the strata will actually insist because they don't want to have the whole block of units being affected by one person putting the air on 85. So that is a big issue here, I think.
Yeah, understood. I think there's definitely some issues there because that it's a challenge with both humidity and heat, and so I think in those cases we'll go back to our original recommendation, which is to choose the size it appropriately and to choose the most energy efficient unit that they can, so that even if they're running sporadically, they don't draw as much energy. But yeah, no, and I understand that there are some challenges with leases and even if when people sort of rent their homes out for short-term leasing or whatever, they will put things in there. So maybe that's another area for the ministries to consider, which is some recommended energy efficiency, a lease template or model lease, so that it promotes energy efficiency without causing issues with owner concerns.
I just want to jump on that comment made by Pierre in the chat about the air conditioning system. That's a really nice point, because what we have seen is a lot of these new builds get AC and they're out of commission within 2 years, where some people have these older units for 20 years. They may be inefficient, but they're still going. So that's interesting to know. So thanks for bringing up that point.
There's a couple comments on why we haven't highlighted the, propane appliances. Yeah, I guess, that's one of the things that we will focus on this guide is more, electrical efficiency. And so we haven't really highlighted the propane, but, it's not an intentional oversight. So definitely it's where we recognize that certain appliances, certain propane appliances are more efficient, and we acknowledge that. There's another point about solar panel wear out faster in Cayman. Yeah, and I think we have. Yeah, of course, and if you, you live also in a storm-prone area as well, so that's another challenge. So, and I think Alex will talk about sort of renewable energy in general in his discussion later. So hopefully we'll remember to add that to the point. Landfill issues. yeah, no, all these points about propane are acknowledged. It's, we're, as I said, we're not intentionally ignoring propane. We're just looking at electrical energy efficiency. So these are the guidelines on that focus. There's a comment also on from Pierre about, so the corrosion coating, so definitely that the selection of AC units should take into consideration that the harshness of the environment that these things will be will operate in, and so I think and builders better than others, than many others, about which equipment have poor reliability and poor longevity. So it is something to as part of the consideration in your after you do all the calculation, of course, the reliability and the warranty and the quality of the system should also be part of the consideration. Yeah, so Flavio says 85 degrees to keep low humidity. Yeah, that's the guideline recommendation is 85. So that's in line with what we recommended in the guidelines. And recommended to keep it minimum 78 degrees when not in use. Okay. Yeah, so I think that's the, this is the types of feedback that we're soliciting, and we're hoping that you'll be able to provide the ministry on the application of the guidelines. And if there's any modifications or changes or before these become code or requirement. So I think, thank you for all of the input that's been provided so far. I'm sure that the Kristen and her team from the ministry is paying close attention to all this feedback.
Yes, and Flavia, thank you for that. This has actually been the most contentious, the whole 85 degrees we've had, 87, should it be 80?
Yes.
We've kind of finally settled on 85, but this is where, we want you all to watch it over the year. See, that mold impact for sure. We don't want to be creating mold. It all depends on your home. But it's basically getting people aware of what works for your home. Should you turn it up a bit? Should you turn it off? For mine, my house gets the maximum of 83. So I put my AC at 83. When I leave it, I know it'll just chip in for a little bit. So thanks for that. We'll keep an eye on this throughout the year.
Yeah, I just want to echo quickly what me and Kristen said. I really appreciate the feedback, the comments. It's super interesting, and like Kristen said, we've had discussions about the set points and other items in the guidelines, depending on people's backgrounds, experiences, and so. But like Kristen said, the point is to raise awareness of what can work and what cannot work.
Right. I think the agreement, the agreement is that I think we all would like to have a set point. We just haven't, the agreement is what is that set point, and it's been, it's been very interesting in trying to reach there. So.
Mm-hmm.
And thank you for all the questions and comments. Hopefully the materials I presented is useful. I know it can be technical and dense, but hopefully it's all in the presentation, and the presentation will be available in PDF format from the ministry's website after we're done. So Alex, I think, unless there's others, I'm handing it back over to you.
Yeah, thanks, me. I propose that we take a 5-minute break, but before we go, I will launch one more poll. This maybe not doesn't apply to everyone, but it should apply to maybe 60% of you based on the first poll that we did. So we're curious to know, for those of you who work either in the building design or construction directly, or in supplying equipment, what share of your work is for retrofits versus new construction, just to have an idea, since we'll be talking a bit later on about existing building retrofits. And so here is the poll.
Yeah, that's a good reminder, Alex, because many of the points that I raise, like load calculations and all of that, it's more suitable for new construction. And then you choose, that when you're doing retrofit, it is sometimes you're reduced to choosing just the most energy efficient unit that can fit the space or whatever. So uh, it's a good reminder about the challenges that some builders do face. So.
So with that, I launched a poll, and I propose that we take a short break and maybe get back here at 11:45. Does that work?
Yes, that sounds good. Also, can I ask people to put their full name under when you add your name so that we can see? We're going to be issuing attendance certificates, so we need to see who's actually attended. I think there's some that says just a first name or office administrator. So if you could just amend that in the Teams app. All right, see you in 5 minutes.
Thank you. Hello again, everyone. So we will start section 5 of the training. So water conservation and renewable energy integration. Then there'll be a short segment on existing building retrofits. And then finally, we'll get to the interactive session where we'll open it up for questions, and if anyone would like to share some experiences or thoughts, ideas about energy efficiency, this will be the time. Okay. Water conservation we consider is also a very important topic when looking into what we can do for buildings, even though it's not as directly related to energy efficiency. It still is in some ways. But first, obviously, fresh water is very limited on island, and the way that water conservation relates to energy efficiency is that water treatment and desalination plants consume a lot of electricity. So reducing water consumption can indirectly reduce electricity consumption as well. So this is why it's important to keep in mind that residential sustainable construction should also include water conservation measures. The key strategies to go about that are fairly simple. It's just to keep in mind to choose water efficient fixtures like faucets, shower heads, low flow toilets. And in terms of appliances, look for Energy Star certified dishwashers and washing machines, which are designed to reduce water and energy consumption. And another item to keep in mind that's interesting is landscaping. So consider using native plants and include them in your projects for shading, for water retention, and so on. Another key measure that relates to domestic hot water is solar water heating systems. So these systems can help reduce reliance on electricity or gas, and are especially effective in very sunny regions like that of Caymans. The images show typical systems where you have plates that collect the heat on top of a roof, and then the lower diagram shows how this heat gets transferred to the domestic hot water tank inside the home. So the key components include the solar collectors, which are typically either a flat plate or evacuated tubes. These absorb the heat from the sun and transfer it to a fluid that then transfers this heat to domestic water, which is then stored in the storage tank. Another key component is the circulation system, which can be either passive, so gravity-driven, or active, pump-driven. And then it's important to keep in mind that you may need some backup heating for cloudy days when the solar water heater cannot produce hot water. Obviously, key benefits reduce water heating costs by quite a bit, up to 50 or 80%. Reduces the carbon footprint by reducing reliance on fossil fuel, especially in Cayman, where electricity comes from fossil fuel. These systems are surprisingly very low maintenance, and they could last for a very long time. I was talking to Sam Small, who's on the call, who we'll talk a bit later, who said that just recently he's got the first leak on his system in 20 plus years. And so these systems are very durable. So you definitely get your money back. And it provides added resilience to your home, so it provides hot water even when there's a power outage. A few key things to keep in mind when you're planning to include a solar water heating. First is to use corrosion-resistant materials like stainless steel or polymer-based materials to resist corrosion from salty air. Got to make sure that it's well secured to the roof for hurricane protection, and depending on the needs for that specific home, the hot water needs, you may need to integrate supplemental water heating, either electric or other. And one key thing to keep in mind is that it might not be a huge issue, but it just, again, to keep in mind that solar water heating can compete for roof space with solar PV systems. And so if you have to pick or combine, then you have to think about how much PV you want to keep versus what you need to keep for solar water heating. So just something to keep in mind. And now in terms of solar PV systems, so when appropriate, they should be considered in the design of new residential buildings or added to existing buildings. So the government is promoting solar PV as a way for the Cayman Islands to reduce the overall greenhouse gas emissions. Currently, there are two programs that exist in Cayman. One is called the Buy All and Sell All program, whereby all the solar PV energy produced by the solar PV panels on a home is purchased by the utility. So in those cases, the electricity produced by the solar panels does not transit through the home, doesn't go through the home electric panel. It goes directly to the grid. And so the utility is buying that power from you and paying you back via monthly bill credits. So that's the buy all sell all program. And then there's a net billing program where customers can consume their own electricity. And then if there's leftover, it gets transferred to the grid. And so they save on energy costs when they consume directly the energy produced, and then they receive bill credits for whatever is left over and then gets transferred to the main grid. And well, these programs are current now, but it's important to keep in mind that whenever you go about one of these programs, or whenever you plan on including solar PV systems, you should contact the utility and make sure that everything works well with their requirements, and that they a few key things to keep in mind when you're planning a solar PV system. The siting, so determine whether the location is suitable. Does the home have sufficient structural strength to support the system? You have to consider the shading. Are there trees in the way? The orientation of the home to optimize energy production, and whether there is sufficient roof area to put enough panels for the system to be cost effective. You also need to consider how you're going to be mounting the solar PV modules on the homes. Various options exist. And then it depends on the roof type. So you just have to make sure that the system you want to install fits with the roof type, or adjust the roof type accordingly if it's a new build. And again, make sure you stay in touch with the utility to make sure that you get all the regulatory requirements right, and technical requirements as well. These are recommended steps for solar PV design installation. Just like Mi's geek segments from earlier, I will not go into this right now, but if some of you would like to know a bit more about this, it will be in these slides, and there's also plenty of resources online And I think we also speak to this in the guidelines as well. Two other things to keep in mind when you're planning a solar PV system. You may want to add battery energy storage systems. Having a battery will allow you to, yes, have backup power when there's an outage. It may also eventually, this is not the case right now, but it typically costs more to produce electricity during peak periods. And so having a battery will allow you, for instance, to fill up the battery during the day with your solar panels and then use that energy during the peak periods. And so essentially reduce peak demand, which is beneficial for the utility, but indirectly beneficial for consumers as well. So that's something to consider when you're planning a solar PV system. And then very briefly, integrated electric vehicle charging. This is growing in popularity in many places. So just using solar PV to charge your EV. That was a short section, and then the last section before the interactive discussion, another very short one. So this is why I was asking you earlier to fill out that last poll. So thanks for filling that out. Looks like, yeah, quite a bit of you are involved in retrofit projects. So that's interesting. The thing is, so most of the measures that we covered for new builds, so bioclimatic design, passive design, architectural level stuff, as well as AC design and sizing, most of these approaches can also apply to existing building retrofits. So we'll not go into these in much detail. I'll just, summarize them quickly. But you could definitely perform roof insulation upgrades and bring the roof to R30 like we did, like the ministry did for the 10 NHDT homes. You could upgrade AC systems to high efficiency models. This could be either through end-of-life replacement if a unit doesn't work anymore, or if you proactively want to upgrade a system to be more energy efficient. Smart thermostats or programmable AC controls can be added to existing homes to allow people to schedule set points based on occupancy and so on. In terms of high albedo roof materials and exterior finishes, this is maybe less common for retrofits, but if, for instance, you need to repair a roof for some reason or change the exterior finish because it's worn out, then in those cases, it would be a good opportunity to choose light colored materials. Another example of retrofit strategies, adding some shading, either through overhangs or very simply through blinds. You could add fans inside the home, either ceiling fans or standing fans to help with circulation, like me spoke about earlier. And so several of these measures are very simple and individually may not have huge impacts, but because they're simple and usually cost effective, they add up. They do add up, and overall, they can definitely generate significant savings for building occupants. Other types of retrofits include window improvements. So you could apply some reflective solar films to reduce the amount of heat from the sun that it enters the house. You could include some transparent window inserts. So those are kind of they're the same shape at the window, so they're custom made, and then they could be inserted inside the window frame, and they kind of stay there because it's a snug fit. And then they add a bit of insulation, and so windows are a bit more performant that way. A few things to keep in mind when you're going about performing retrofits, either for insulation or AC or others. These are good opportunities to inspect ductwork to prevent energy losses due to leaks. So to seal the ductwork, reseal the ductwork as needed. This is also a good opportunity to check for humidity buildups or molds, which may inform adjustments to the AC operation or layout or unit size and so on. And one thing and that's maybe another poll question that I should have thought of, but I'd be curious to know how much of you make the effort of educating homeowners on what behaviors to adopt to be more energy efficient, whether it be AC set points, scheduling operations, and so on. But in any case, retrofits are a good opportunity to educate homeowners. And here are some key behavioral improvements that can really reduce cooling consumption. Like we talked about, you recognize this table now, which is open for debate. But selecting set points that work well for you, that are, you could schedule set points based on your occupancy. Make sure that you replace AC filters regularly. Clogged filters can definitely increase consumption by 5 to 15%. So again, all of these numbers can add up, and all these measures can definitely improve energy efficiency when combined. Another way to reduce cooling consumption is to check seals on windows and doors and repair them as needed, kind of increase air tightness. And those are other behavior adjustments that homeowners can be made aware of to reduce overall electricity consumption, such as checking the seals on the refrigerators, making sure that they fully turn off the lights, the appliances, electronics when not in use. All of these can definitely generate significant internal heat gains and increase the cooling load. And simple things, again, like closing the blinds when sun exposure is high. So again, retrofits are an opportunity to just remind people, or like many may not be aware that these simple things can reduce their electricity bills. So definitely useful for that. And that's it. That's all we had for the proper training portion of this training. And now we have the rest of the session for sharing case studies, sharing questions, and discussion. Yes,
I
Mario.
see a hand up from Mario.
Do you want me to pipe in at this moment?
Hey, Alexander.
Wait, Mario,
Yep.
1 moment, Sam. Yeah.
Okay.
Go ahead. Mario?
Yeah. Okay, Alexander. Yeah. Just a quick question about the retrofit projects.
Of course.
We have an experience actually on how we normally do the retrofit. Like for example, we have some projects over here that doing the assessment or condition assessment of the buildings. Okay, that it's a complete discipline, by the way, for MEP. What we normally observe is that during for a project that is retrofit, in doing the analysis of energy efficient selection of the equipment, I noticed personally that the the saving itself is evident for a minimum of 5 years. What I'm trying to say here is that we cannot guarantee the immediate effect of energy saving. It's just because you change the light from fluorescent to LED, but the cost of having this LED light has a great impact in the power system of the harmonic. So you have to mitigate the effect of that harmonic in the system. So the cost of upgrading the system to get rid of the harmonic is the cost that you are saving for that particular saving. So the saving itself is not what we expect a year round turnover. It may take time because you need to recover the cost of upgrading your system by mitigating the harmonic effect in the electrical system. Yeah. Do you have any idea on this?
Let me take a quick step. So,
Okay.
yeah, I think the example you use, which is lighting. Most of the time, the way, I guess, my experience, that especially in places like the EU, is that things like lighting LEDs, the capacity of the light bulbs are low enough that it takes a lot of them to affect the harmonics of the system, so that the EU actually has regulations in their harmonics in equipment. Usually they target equipment with much higher capacity, higher wattage rating. But I understand your point. They're certain introducing certain pieces of equipment. Yeah, it's like does for lack of better words, to introduce some disturbance into the system.
Yeah.
And yes, so that with a system with a distribution system that is not set up to deal with those harmonic distortion, there's additional investment that has to be made. So you're absolutely right. The thing is that that investment is not seen by, or it's not really borne by the house, the homeowner.
Yeah.
It's on the system, it's on the provider. So yeah, so that I'm sure the utilities have, they have to go to the Public Utility Commission, and they have some cost recovery whenever they improve the system. They have some cost recovery mechanism that they require, or they ask the Public Utility Commission to allow them for cost recovery. But you're absolutely right. There's some trade-off there. We recognize that. We're dealing with mostly on the consumer side, so that's really not an issue that even builders deal with, right? So it is, but it certainly is some point to keep in mind.
Yeah. Thanks, Tom.
Sure, and again, thanks for bringing that up. Yeah, you think, oh yeah, it's something very simple. We'll just replace the light bulb, but it's a butterfly effect. It cascades down the stream. But yeah, so it's definitely things that we need to be aware of when we change the system. But thank you for bringing it up. Yeah.
Exactly. Energy saving is not just one part of the overall procedure, but there is an implication to other system.
Any other comments or question on what Alex has gone, or even going back, if there are things that now just occurred to you that you should have asked earlier? Definitely please bring it up. That we've left some time because we understand through this we learn through this process that there are many opinions, and we tried to incorporate as many as we could during the discussions with stakeholders. Alex had face-to-face meeting with some of you when he was on island. So we're hoping that a lot of that is reflected in the guidelines, but, sometimes it doesn't quite completely, we can't claim that we completely captured. So I see Hussein has his hand up.
Hussam, actually, but there's another Hussein on the line. No problem.
Sorry, yeah.
No worries. I do have a question. So once we start implementing these items, which are currently guidelines, which eventually you guys had said earlier, they'll be policies. Until they become a policy, which is very important, I think as architects and designers, we're automatically going to educate the person who is investing in whatever they're building or designing, and we will always promote best practices, of course, from a 360 point of view. But this is more of being aware of the current situation of how existing buildings now are being retrofitted, or let's say, for example, apartment complexes or whatever kind of developments that have went over a few number of years that have older appliances, etc., that are managed by strata. So the way I see this, there's two parts. There's us as educating the person who's investing in such things, and there's also current people in the market that are really not aware of this. And us to get into that niche and educate them to change things out is going to be difficult because change is sometimes scary, right? And sometimes it can be expensive. So is there a plan for this, for these guidelines to, until they become a policy, is there baby steps to, for example, reach out to stratas or developments or something that has been already developed and at least starts with little things like changing energy efficient appliances instead of using appliances from 2001 or non-energy efficient items, because being on this island, housing is very expensive, whether you rent or buy. And many times when you go rent or buy, everything is out of date. And when you rent, you're paying premiums, yet you begin to realize that there are initial cost savings short term rather than long term for the habitants. And that's very important, right? For anybody residing in a household. So one idea that I thought of was maybe reaching out to stratas, and as part of their regeneration, there would be some sort of mini changes, like I said, changing out appliances, maybe changing out ACs, testing them, making sure that they're efficient. I mean, many of the stratas, they do come and inspect and do all these things. But like Raphael said earlier, many of us residents, we have to keep it at 78 degrees, running 24/7. And when you're doing that with non-energy efficient items, for the current people, not the new construction, a lot of the new construction actually is moving forward, I think, in the right direction. Maybe not in terms of insulation wall thicknesses, because I think a lot of the new developments now, they're seeing lessons learned of the past of what's being rented out. And so they're building plans for 1 bedrooms, 2 bedrooms, 3 bedrooms that are working, being rented out business-wise, and they're building it as such, and that's what's happening now. And I can think of 3 developments that are ongoing right now that are not really taking into consideration the wall thicknesses, installations, etc. However, they are moving in the right direction in terms of appliances, ACs, aerators on the sinks, small baby steps, which is a nice change. So what would be, I guess, the baby steps until the guidelines become a policy, or if there are any baby steps to kind of start enforcing certain guidelines that could potentially infiltrate the market until that becomes a policy? Is there such a plan?
I can take that one. So yeah, this is the first step. We've actually just, create the guidelines,
Right.
and then we open this training up to everybody. So developers, everybody is invited to this training. I like your idea of trying to reach out directly to strata. So that is our plan, to keep pushing this, to reach as many as we can, especially the rental market. It's hard to
Yeah.
get into that one, and that's a big one. So yeah, I really like that idea. And I'm sure we'll link up with all of you that are on here to come up with more energy education campaigns and the best way to reach people. Because one of those things, people aren't really interested until it really affects them. There's
Absolutely.
so much in the news. And so we just try and keep pushing and pushing. But yeah, thank you. We'll for sure stratas and educating that way. It's a good idea.
Perfect. Thank you. And I think that's kind of like one of the ways to go, because like you said, the rental market and the housing market is huge. And I think stratas can actually help, you know, a whole other category of demographic of education and really bringing things up to speed. And just another idea, just, you know, just also about your presentation to codes and regulations. So we understand this as architects, designers, and developers, but many of the people, you know, of the everyday, they're not really going to go and dissect it, kind of like, you know, reading in between the lines. So one of the strategies that, so my previous experience was in the Gulf MENA region, and there is actually a development called NEOM in Saudi Arabia, and it's a brand new city. And one of the things that we did was kind of basically what you have done, which is write a series of guidelines. But to simplify it for people who don't want to go into the guidelines and read line by line or look at diagrams, we've provided a series of approved suppliers. So approved suppliers for ACs, HVAC, materials, etc., that meet the standard of energy efficiency, economics, and also from different price ranges, from low to high. And I think that kind of menu would really help guide a lot of the people, even doing renovations, you know, to take a look and say, oh, there's different price ranges, there's different options. Let me just choose this. It's good for me, good for them, etc. So maybe that's another way of simplifying the strategy moving forward as well.
Awesome. Thank you so much for that recommendation. That's a good idea.
Yeah, no, those are really good. Yeah, no, let me add to you know, what Kristen just said too. You know, we had suggested as part of our task in doing all this work, one of our tasks was to come up with a recommended, you know, implementation plan or implementation strategy for the ministries. And so we have put some of that, but I think this is, you know, one of the key, you know, key factor to success, right? For any of these plans is stakeholder input and buy-in, right?
Correct.
You know, and voices like you, Hassam, and input from builders, suppliers, and that's what that, you know, that what makes the baby steps work, is because, you know, even if you're defining a baby step, it, you know, you still have to take that step, right? So it is
Correct.
what people are comfortable with. And so part of the idea of the, you know, transforming the market is that you have to create the right conditions. That's why the ministry has created this thing, the homeowner infographics, which we start the consumer education part, right? You have to create demand. You have to create awareness, then you create demand, and then you have to have supply to meet that demand. So it's, you know, it's a series of steps, and that's, you know, I mean, I think this, as Kristen said, this is one of the first steps that the ministry is taking in, you know, in moving this market. I mean, it's a huge sector, many stakeholders, and you can't, you know, you have to be able to move forward with at least awareness and support. You know, it you know, it's not what's happening in the U.S. now, where, you know, one person declares, oh, we'll close the Department of Education, and it happens. You know, even though everybody's against it, that, you know, that hopefully that's, you know, that's not what's happening here, right?
Correct.
So anyway,
and that's exactly the point. I really appreciate all of this, and it just comes down to basics. Because just one last comment, for example, you know, the strata that I'm renting from, for example, I needed to change my sink. They ended up getting a sink for like, I don't know, 50 CI, and they put it on, and there wasn't an aeration, and it just gushed out water. And I had called them up, and I said, you know, if you were to spend 20 CIs more from, you know, a place here that we have called ALTs, it's kind of like a Home Depot. You could have spent 70 CI, you would get around better quality, better longevity. It wouldn't have rusted. You get to save water, and I don't get to use the resources, because being on this island, you start to understand how delicate and fragile our resources are here, and how delicate the place is. So every little bit counts. So I think this is great. So thank you for that.
great.
Fine. So, are we good?
Yes. Do we have other comments?
I mean, yeah, we had asked Sam if he could do short 5-minute presentation on talk to about his experience as a designer and stakeholder in the industry. So yeah, Sam,
Yeah,
if you can,
okay.
now would be a good time.
Going to take a few minutes. So I came late to the conversation, but I think I came in as you were talking air conditioning. The problem Cayman has, it has
Sorry,
several
Sam.
issues.
Do you want to just, I don't know, maybe everybody knows you because they know you, but
Oh,
just in case, do you
okay.
want to introduce yourself quickly?
Okay, no problem.
Yeah.
My name's Sam Small. I've been here 28 years. I'm a civil engineer, but I'm a lifelong ecologist as well. I was a general contractor for 30 years, and I'm now switched as I've got older to a consultant. I've owned a house in Cayman for 20 years, and I've experimented on my own house to make it more energy efficient in lots of different ways. So I've identified areas in Cayman where we don't quite get it right. For instance, we're a wealthy country that works on consumption tax, and so there's no tax credits for systems like you'd have in Europe or North America. We do have duty concessions on products, but that doesn't always help come through. Also, because it's grown in a tiger economy, a lot of businesses have started from one or two people and grown. And so there isn't really many people on the island that understand building science or building technology science outside the mechanical field. And also over the years, Cayman has become more and more addicted to electricity. So a lot of the energy efficiency is based on reducing electricity from an electrical point of view, where we could actually save a lot of money in residential construction by going to the old-fashioned method of trying to reduce the energy consumption through passive methods. And so you could then size a solar panel with as small as possible because they were expensive. Give an example of this. When I bought the first solar panel, a 250 watt solar panel cost $1,000 US, and now it's, I don't know, $200. So we don't although we follow the North American Building Code, we don't follow it quite correctly. For instance, we're very keen at putting soffit vents into houses, but we don't put in the ridge vent. And so therefore the inside unvented attic becomes a superheated pressure heater instead of a chimney. I just went to A.L. Thompson's yesterday and looked up what they had, and they have solar powered attic vents, which have a thermostat that switches on at 100 Fahrenheit, and then switches off at 85. So for 800 square feet of roof, you can buy one of these for less than $200. And so why is that important? Well, the way we design houses in Cayman is we put the air conditioning ducts and air handling units in the attic. So you have a house that you have an air conditioning unit that produces AC around about 58 Fahrenheit. You have a house that's got a thermostat that the discussion I came in was 85 at the max and preferably around 78 as a point. We can't cool it too low because we're a high humid area, and so the dew point in Cayman is typically about 72 degrees. So unless you want water on the inside of your building, that's not recommended. So We also, in Cayman, as I say, we don't do the ventilation correct. And the ventilation is key to reducing the temperature in the attic and therefore reducing the mechanical load on the air conditioning system and reducing your cost. If we look at the North American government and we look at South Florida, which is probably the closest to what anywhere is, they have a climate zone of 1, and they recommend for an attic that has no insulation in it to have R30 to R49. And if you have an attic with R19 in it, top it up with an extra R19 to an R38. So that's basically putting in not just the R30 bat, but putting the R19 bat on top of it. So to give an idea of cost, because cost is the thing that drives Cayman. Based on A.L. Thompson, R30 costs $1.50 per square foot of ceiling space, and R19 costs $1.10. If you go bubble wrap, which gives you like an R5, but works in a different method, that's 50 cents a square foot. We used to sell a ridge vent on this island because that's where I bought mine, but I couldn't find any. So based on importing some from Home Depot, it worked out at $5.20 a linear foot. So what does this all mean? Well, before I started my experiments, I was recording 140 Fahrenheit in my attic. And my experiment was to get my attic down to shade temperature, which is what you read in the forecast, which is a shade box taken at the airport, to say about 95. The key point, so I installed a ridge vent. I've installed bubble wrap to the underside of the soffits to accelerate the convection, and then I installed R19 in the attic space at the time, and I managed to get the attic space air temperature down to 108. Then I just couldn't get it any lower, so then I looked at the next thing, which was I increased the insulation to my ducts in the attic. Now I should point out I have zinc ducts in my attic just because I don't run the air conditioning. I don't like air conditioning, and I don't run the air conditioning all the year round. So I didn't want mold building up in the ducts. So I chose a zinc duct as an antibacterial thing. But then I wrapped that with R7.5, which was the best I could get. So I managed. So my goal is to have a utility bill less than $500 a month or less. So once I'd solved the issue with the attic, which as we see from the prices, is very easy to do with retrofitting items, and the cost analysis of benefit on that is a matter of years, which is the other issue we have in Cayman. When we design buildings in Cayman, we only design them looking at the capital cost to build the building to meet the building code, which is the minimum legal standard. We don't look at the recurrent costs inside a building for 40 years, which is the usual design life of a building. And so the poor occupant, or the poor renter, as we've discovered, lives in this building, moves in, and then has incredibly expensive electricity bills due to the appliances and the lighting. But the main cost in Cayman, the biggest cost in Cayman for power, is a swimming pool. But most people don't have one of those. So the next biggest cost in your house is your air conditioning. And the third largest cost is the clothes dryer. Now, a clothes dryer uses about 4.5 kilowatts per hour to dry your clothes. And we live in a sunny environment. You can hang your clothes outside and they'll be dry in 15 minutes. So what I'd say suggest for these guidelines, because they have to be affordable to the general public, both for new construction and retro construction, be first to insulate your attic, and then that will drive down your air conditioning bills. And also install a ridge vent or a ridge fan. Now, these ridge vents are hurricane proof. They're made by GAF, they're made by CIG, they're made by all of them. And so what the building code actually says is you're meant to have a vent every 300 square feet, but it's meant to be equally split between a soffit vent and a ridge vent. And none of the houses, I suspect I'm the only house in Cayman that has a ridge vent. So that's an incredibly cost-effective method to reduce your energy straight away, even before you go to looking at air conditioning appliances. The other problem with air conditioning is we're too hot in Cayman for the SEER rating to apply to us. So we have to go to like Southern California and go with the EAR rating, because I think the SEER rating is designed at 82 and we're around 90, so it doesn't really apply to us. So we have to be careful when we're looking at importing energy efficient appliances from the States that they're designed for the geographical region we're in and not for the medium data line along the Georgia, California cold climate. I mean, for instance, we have like 3 cooling days a year, and the rest of we have 3 heating days a year, and the rest of the temperature is cooling days. So we need to look at, when you're putting in these guidelines, we need to look at the geographical region you're in instead of just adopting North American policies. Or if we're going to North American policies, we have to look at ones for South Florida and Southern California, because they're in the same sort of temperature climate as we are. So solar hot water. We don't freeze here ever, so we don't need a closed loop circuit. We also have a pressurized water mains, so the open circuit method works for us. I had a cold day. We had a cold spot the other day, and I went to plug my water heater in, and I discovered that I couldn't actually reach the socket to plug it in. I'd moved the water tank about a decade ago, and I no longer could reach the power point. So I have a 40-gallon tank on the roof, and I have an 80-gallon fiberglass tank, which is a water heater, in my house. So I have 120 gallons of hot water, which gives me about a 3-day supply. I installed the fiberglass tank, which cost me twice as much as the steel tank, in 2002, and I've never replaced it. And I installed the water heater on the roof after Hurricane Ivan, swearing I'd never have a cold shower ever again in my life, which is not really that cold here. But you notice the difference between the winter season and the summer season of how much you have to temper with the cold water to make it work. That costs you about, when I installed it, it cost labor and materials cost around $4,500, and that was in 2006, so 19 years ago. I've easily paid back that system many times over with not having to heat water. Instantaneous hot water heaters, which are very popular here, only work if you've got 1 or 2 people in your house. But if you've got a family of 4, you're going to be running that instantaneous hot water heater too long, and you should really go with a storage tank. But people aren't educated here, that they're sold with some new fad that's going to save them money. So in order for guidelines, you need a lot of education. You need a sea change in our way our construction industry works, which is currently to build a building and flip it and make as much money as you can without looking at recurrent costs of the occupants living in it. We need to look at the building codes to put in the measures that are current, because our code is a 2009 code and we're 20 years later, but we need to go with a minimum of R30 in your attic post nothing. A ridge vent, both things are very cost effective. And then once you've got that in place, you can then start looking at all the other elements that you've discussed today. We used to have cisterns in Cayman, but then they started spraying mosquitoes. And because we live in a drought, flash flood, the mosquito spray would end up on a roof and then get washed into the cistern. And so people were suffering from leukemia at very high rates here. And then they also brought in the piped water with the water authority. And they banned cisterns for a period of time. Well, they didn't really ban them, but they said you couldn't have one. But legally you were allowed it. So that's probably a mistake. We should encourage people to put cisterns back in underneath the houses. If it's not for drinking water, definitely for non-potable uses, because all our potable water here, all our water here is reverse osmosis water, which requires large amounts of diesel generated electricity to produce water, whether it's used for potable or non-potable uses in Cayman, which causes the country to have a very large carbon footprint. So encouraging new build and encouraging sustainable or sensible things would be very cheap. So basically, oh, and then solar power. Solar power is an interesting one, and there's a lot of misconception out there. We have two laws in Cayman. We have a generating law and we have a transmission law. And the generating law says you're allowed to produce power on your own property as long as it remains on your own property. And then the generation law says CUC is the only people, sorry, transmission law, CUC is the only people can transmit it. So that's why you need an agreement with the local power provider if you want to sell your power. But the interesting part is that in the generation law is you can be off-grid solar and use it, and CUC still have to provide you power to your house because it's just the equivalent of switching off certain circuits. They allow generators. It's weird in Cayman. They allow you to have a diesel generator, but they get upset when you have solar power and you want to. So you need a lot of education, getting rid of a lot of urban myths, slight tweaking to the building code, and then that will get you your minimum guidelines. And then over the next 20 years, you just increase them slowly. But if you try to force everything on everybody straight away, it's not going to work. You have to do, as we say in NATO, the salami method, where we do a thin slice at a time and then nobody notices. And that's basically it.
Thank you, Sam. You're absolutely right. I liked your point about the cisterns. I didn't know that about the mosquito spray, because there was a lot of misconceptions of why we had banned cisterns. But definitely for watering and flushing toilets, we could be promoting cisterns more. So, yeah, thank you. Thank you for that.
So when I was at university, as a civil engineer, you study all these things. Back in the 1980s, the average water consumption in the UK was 625 litres of potable water per day per person. And of that, only 25 litres was used for drinking and cooking. So 600 litres could have been done with non-potable use. So in Cayman, that would dramatically reduce the energy consumption of the country. Okay.
Thank you, Sam.
No worries. Thanks.
Yeah, thanks. You're actually making the case for us. So thank you so much.
Well, that's what I was told to do.
Yeah. Okay.
Okay.
Other questions, comments? I know that Chris has been talking about, how we're not incorporating enough points about the use of propane. So I think that's much appreciated. We'll well noted. We'll make sure that, that's part of the discussion going forward. Are there other points, questions, things that we not clear or were overstate or anything like that? Please provide us with the feedback. I actually have a feedback survey post. I'm going to make you guys do another survey because there's a post-training survey. I'll show the QR code in a little bit, but I think if there's,
I can share the
Alex,
link now. Yeah, I'll share the link now in the chat.
okay, yeah, and then I think maybe Kristen might want to have some final closing words, and we'll finish this up.
Excellent. Thank you so much. That went by a lot quicker. I thought 4 hours would drag on, but it was very quick. And thank you so much for taking the time to present today, and for everyone for your participation, your comments in the chat. I've been watching them. Some great comments coming up there. So we do have the next training on next week, Thursday, which is aimed at suppliers and retailers, but anybody is welcome to join. So I will send out the presentation and the link to that for those who do wish to join that session. And please continue, if you think of things after this, feel free to email me at any time, and keep the discussion going for sure about energy efficiency. That's it. Thank you so much.
Thanks so much, everyone, for the contributions. I know it's redundant, but I want to say it's super appreciated to get some interactive exchanges and to get your input and your thoughts. So that really makes it more interesting and useful for us as well. Thank you.
Great. Thank
Stephanie,
you.
did you want to add something?
Yeah, I just wanted to thank everyone for their participation, and we really hope the training was useful, and that now you really want to go and look at download the guideline and look into it, which would be a great idea since we'll be back in 1 week. So if you have more questions next week, after reviewing the guideline and the presentation, we'll be available to answer questions and more specific questions. So yeah, I encourage all to do that.
Yeah, next week it's only 2 hours or less.
Yes.
So,
but we'll keep time for questions as well.
Yeah.
Just in case. Thank you very much.
cheers,
Yes,
everyone.
I guess Kristen, once the presentation and the recording will be available, you'll send a notification to everyone, or will it be on the same page as the guideline so people know where to find it? Oh, you're on mute. Oh, Alex, there's an issue with the training.
Yeah,
Maybe
I think it's on. It's not on our side. Yeah, I set it so that everyone can respond, right?
Yeah, but it doesn't seem to be. But if you go on the last slide with the thank you, I had put a link there. So
Okay.
maybe I don't know if participant can just click on that link or not. Because I know when I opened it, it was only for Econoler people, so I don't know why, and I had to change it.
Okay.
So it
I thought I changed for both of them, but we'll check it.
Yeah, it may actually be yours. I just assumed it was internal because I have had that, but it just says I don't have permission. It doesn't say why. So feel free to check it or email it to me.
Okay.
And someone just Susan wrote that the link works. So
the one Alex sent works. Yeah.
Okay. Great.
I don't know if you. Yeah.
Okay, the one Alex sent. Where did he send?
Yeah, I think
so
if you guys can paste that. I think if you guys can paste that for everybody at the end, I found it. I think it'll be easier, just to avoid confusion.
Okay.
Thank you, everyone.
Yeah, so we'll paste it again, I guess. Okay, Kristen, did you want to add something? Yeah, here's the link again, so hopefully you can fill it. I think Kristen disappeared.
Okay.
Well, enjoy the rest of your day, everyone.
Yes.
Have a good lunch, I guess.
Thanks
Bye-bye.
again, Shondell. Really appreciate your input. And Sam as well. Thank you.
Thanks, everyone.
Thank you, everyone. Have a good one.
Thank you.
Take care.
Bye.
Bye-bye.